So one of the major uses of MBD simulation is the automotive world. Okay, so before I start talking about this, I want some inputs from your end so that I want to know that you guys are also involved in this webinar, because I always like my webinars to be interactive. So most of these are already available. So the advantage of using Altair's Motion View and Motion Solve is because some of these popular suspension, for example, the double wishbone suspension, the MacPherson suspension, these are already available in the MBD software library in Motion View, and you can directly use them for analysis. So there's no need to waste time for building the model and then trying to analyze it. So you have already the built-in models in the MBD software library. You can just import that and start doing your analysis on that. So that's the advantage of Motion View here. And so MBD simulation is basically also widely used in the vehicle dynamics analysis. So I hope you're all familiar with, or somewhat you have a fair idea of what vehicle dynamics is. So either it can be the component level, such as suspension system or the steering system analysis. So wherein you'll have to determine the stress and strain in the control arm. And it can also be for a full vehicle MBD, like the handling analysis, wherein you'll have to calculate the body roll, pitch, etc. So I think here, if I just click on the side, you can see some of the examples. So on the first example, which you see on the left-hand corner is the suspension analysis. So the steering is also included. So it's a suspension and the steering system analysis. So, and this analysis in particular is the static ride analysis, which is one of the most popular analysis in suspension analysis. And the second one, what you see here, is dealing with engine dynamics, wherein you can get the stresses that are created when the simulation happens, and also the forces that are exerted on the mounts. So this is under the engine dynamics. And full vehicle MBD, as I mentioned, you can calculate the body roll, pitch, etc. So moving on to the next application, that's aviation. So basically MBD is also widely used in the aerospace as well as in the aviation industry. So in the aviation industry, it's mainly used to design and analyze the mechanisms of landing gears, seat ejection mechanism, flight simulators, and also the helicopter fuselage. So all these can be simulated in MBD, and you can get the forces that will be generated at the tires when when an aeroplane lands on the ground. So all these can be obtained by doing the MBD analysis. So moving on to our next application, defense. MBD again plays a major role in the defense sector as well, and most of our defense industries use this technique. So for instance, say we want to build a system using MBD that is used to track the target and hit the target after the missile is launched. So we can predict the parameters such as angle, velocity with which the missile has to be launched in order to hit the target. And all these parameters can be calculated, but of course with some assumptions. And you can also model and also simulate the complicated battlefield vehicles using MBD. Next, moving on to our next application, which is manufacturing. So in manufacturing, MBD is used for designing chain and the belt drive systems, the conveyor belts, and also other machinery equipments. So in MSc Adams, there are also built-in macros. So that's one more advantage of using Adams over Motion View, wherein we can build macros. There are already built-in macros there for the chain and the belt drive systems, and you can also build your own macro to create new systems once you become go to that advanced user level. So these macros can also be built in Motion View as well, but some of these are readily available in Adams.